Salk Institute in La Jolla is one of a few private research institutions participating in the country's Brain Map initiative. Salk will chip in $28 million to kickstart the initiative. Here to tell us how one goes about mapping the still mysterious human brain is Terry Sanowski, a Salk neuroscientist who was with President Obama yesterday during his announcement. Terry, that had to be so exciting.
This was an extraordinary event, and there were 240 scientists and just an extraordinary, the head of the NIH, the head of DARPA. It was really a wonderful event.
Quite a collection of brains, if I may say so. Now, eyes often glaze over when people say neuroscience research. Like, what is that? How will this brain mapping be different than what we already know about the brain?
Well, the difference is in the N in brain, neurotechnology. So this is bringing to the brain a whole new set of tools for being able to record and influence many neurons at the same time.
Let me stop you there, because what do we know right now about the brain? Don't we know quite a bit, like what parts of the brain control speech or eyes or movement or things like that?
We know where this happens, but you don't know how it happens. And so we need to be able to zoom down from this large macro level down to the level of single neurons and to be able to record simultaneously from millions of them.
Sort of like at the street level. Now, Google Maps, using that analogy, they have their satellite, they have the truck that drives around. What kind of tools are you going to need to be able to get this sort of street level view of the brain?
Well, that's where this new technology is really essential. So we know a lot about the molecular organization, which is really down at the level of how the molecules interact with each other. We know a lot about the brain areas, the visual area, the auditory area, the motor area, but what we don't know is in between, where the neurons interact with each other in very tight little networks, where hundreds of thousands of neurons are communicating back and forth, and the technology that we're developing will allow us to be able to get a picture and to see what's happening inside the brain while you're actually having some percept or behavior or making a decision.
Now, we do have a picture, actually. It's sort of a preliminary map, I'd like to say. Let's take a look at this picture and tell me, what is it that we're looking at?
Well, what you're looking at, first of all, is a microscopic image of a part of the brain called the hippocampus, where we know long-term memories are stored temporarily, and the actual neurons that you see.
So these are nerves. The green is the nerves.
The green, the circles are the cell bodies, and the little lines are the dendrites. These are the actual mechanisms whereby neurons communicate with each other, and information flows in. It gets transformed. It gets stored. It gets transported out, and this is kind of the ground zero for memory.
So we're talking about this is ground zero, and we're starting there so we can have a nice map. What does this branch out to, realistically, what it would mean in Alzheimer's, depression? Where do you take this map? What will it be for?
Well, the first step is to literally get the map at this very high resolution. Look at the activity as it changes with time. We have the Dynamic Brain Initiative at the Salk Institute for being able to use optical techniques for being able to do these maps. But this is just the first step. The second step is to influence those neurons. We think that in some disorders, such as schizophrenia, autism, that there's an imbalance between the neurons that are excitatory and positive and the inhibitory, which are negative. If those two are not in balance, the circuit can't operate normally.
So you could see it and hopefully define those a little bit better.
We should not just be able to see it, but able to reestablish a balance by influencing those neurons.
Let's bring this back to San Diego. You're not in this alone, certainly. It's a 10-year project, $100 million in the federal budget for this, just for this year to get it started. Who else in San Diego is working on it, and how is that going to impact maybe the economy here?
Well, UCSD is a very important partner. First of all, the Kavli Institute for Brain and Mind, which is been very influential in catalyzing this national project, is really organizing a major effort within UCSD to bring together the engineers that we need to work directly with the biologists and the neuroscientists. We need to be able to build these tools, take them into model systems, starting out with simpler creatures like mice, but then ultimately scaling it up so that we could use it on humans.
Could this mean jobs, though? Not just at Salk, not just research, but bringing in the whole
it's going to go in
support?
stages. First, it's going to be bringing in new faculty, students. Second, it's going to create new startup companies. There will be a neurotech industry around San Diego, UCSD, just as there is a biotech industry. So this is really an extraordinary expansion that will take place in our community.
Absolutely a new beginning. I'm sure we'll be talking to you more about this. Terry Sanowski, Salk Institute, thank you so much.
Well, it's a pleasure to be here.